Hi, this is James Hoagland. This is my capstone video for my final capstone project. My project that I developed was an automated hydroponic gardening system. The reason why I discovered this project was behind my personal interest in vegetable gardening, and heard about hydroponics being a way to do gardening that's much bigger in product and uses a lot less water, up to 90% less water. And I thought, wow, what a possibly a great way to also be able to feed the hungry people, or be able to grow food in locations that are not arable. So I started thinking about how I might be able to create a hydroponics setup, which is basically growing vegetables or growing plants without the use of any soil. What it actually uses is a nutrient, concentrated nutrient solution that's placed in the water that's applied to the roots of the plant. And I tried to figure out a way how I could automate this process to make it as simple and inexpensive as possible for anyone who might be interested in basically just putting some water and some real basic setup and plugging it in and getting it to actually produce food. So I'll go ahead and show you what I've got. Okay, so here's my basic setup. What it is a 5-gallon Home Depot bucket with a hole cut into the lid of it, where I've placed a planter with some inorganic media and a tubing that I've drilled holes in that allows water to run down through the media and into the inside of the bucket. There's water inside the bucket, as you can see. There's a couple of sensors down there. There's the total dissolved solids, the pH sensor, and that's the water level sensor. Pulled the water down a little below the water level sensor so we can see the system auto refill. It'll top up the system and keep it going with the right amount of water in the bucket. The actual reservoir itself is here. That's just a regular container that I've drilled a hole in for the hose to pull the water out of. It's just regular fresh water. And this is the main brains of the system. What we have here is the real automation. Up here in the upper left hand corner, that's my 120 volt AC power supply that's a step down to a 12 volt DC power supply that powers all the pumps and solenoids. Over here you see the 3 solenoids and the pump. What it does is it runs off these 4 relays from the Arduino board down here, so that whenever it needs to cycle the nutrients, it'll kick on the pump, this pump here, and open one of the 3 solenoids based on where it needs to get its source. There's basically 3 sources. The first is the bottom of the tank here. That's your main nutrient reservoir. It pulls water out of that up through this tube here and then through the solenoid, where it then comes down to the pump, which then pumps the water back into the top here, and then it drips down into the planter. That'll happen every 30 minutes. That'll run for about 5 minutes. That just feeds the root system of the plant. The seeds actually go in here. You put the plant seeds and everything will grow right out of this container. The other is obviously the nutrient solution. This is a real common, high quality, concentrated nutrient solution that goes into this other pipe here that goes into the nutrient solution. And once a week, the pump will kick on and suck a little bit of that nutrient solution out of there and feed it back into here where the reservoir is. But that keeps the concentration, because the plant will absorb that nutrient, and that's what it uses to grow. Then the final third part of the project is to keep the water topped off. So this is where my water level sensor is that comes in right here, and then it connects to the Arduino. That lets me know when the water level needs to be added for any condensation that happens, and the water will just evaporate out of the bucket over time. So it'll pull out of here. Again, the third solenoid will kick on, the pump will kick on, and that's where it'll get its water to top this off until it goes above that sensor. Those are the 4 relays that control the pump and the 3 solenoids. What I also had, something that was important to me, was to be able to report the information on a website so that I'd know what was going on. What I actually have is a little tiny Wi-Fi adapter down here. You can see it. It's very tiny. It's about the size of a thumbnail. And what it does is it connects to my Wi-Fi network and sends information to my website via TCP. It was quite an effort getting that going, but I finally have it working. It reports quite well. I haven't had actually any problems at all once I finally figured out how to get it to post to my website that I built. So what I guess I'll do is I'll go ahead and I'll plug this in, and then we'll see this thing work. Originally, since the water level is low in the container, it should go ahead and kick on the pump and top off the water level. What I also did was, instead of using up my nutrient solution, I just got a cup of water, and I've been using that for my test. So I didn't waste my nutrient solution. I just put the cup there with the pipe in it so that I could see that it's pulling water from what would normally be this nutrient solution here. And then we can see the 3 different locations, this, and then from the bottom of here, where it will pull its water from. So we'll go ahead and I'll plug it in. I've got my power source plug right here that'll power on the Arduino. It should start up my process. I believe I have it just temporarily set to kick on and run a cycle every 60 seconds, plus another 90 seconds for the nutrients. And so we'll see what happens. There we go. We see it started up. Our lights came on our relay. We're getting water. The water's coming in from my freshwater reservoir. and is draining into the nutrient reservoir. This should be filling up down here in the bottom of the bucket. See the water coming in, and it should stop once it gets to the top of that sensor, and that's what it's done. Here's the next one. That's the feeding cycle, which I put some green food coloring in there so you can see that it's actually sucking nutrient solution from the concentrated nutrient supply and feeding that down into there. So now we have nutrients in our system. Then what would happen next would be that every 30 minutes it would just do a freshwater recycle, where it's pulling water in from the actual reservoir and just pumping it right back in. That's just sending water from the bottom of the bucket to the top of the planter, so that once this starts growing, the plant starts growing, that'll give the nutrient solution and water to the actual plant that it'll use to grow. And as you can see, it's automatically shut off. And we can also see, if we go to the website here, the website URL is myhydro.x10host.com. It's just a free web hosting site called X10 Hosting that I use to build this little application. Have it going again just for a few seconds. It's just pumping water and cycling. Back here to the website. This is the main home page, MyHydro automated hydroponic garden system. From here, I made a link over here on the left-hand side to view the current response data. From there, if I click on that link, I can actually see all the information that's come from the system to my website. From there, every hour, it sends data from the sensors. I've got the temperature sensor over here on the side with the humidity. That's a DHT11 temperature humidity sensor, and the TDS and pH sensors down here in the bottom of the bucket. Get a picture of them. They're down there quite a ways. There's the pH sensor, and there's the TDS, total dissolved solids. Those are the two main important ingredients of the hydroponics, the pH and the total dissolved solids. But I'm also getting the temperature and humidity. The values aren't quite right. I'm going to have to go back and figure out why the sensors aren't producing as accurate results as they should be on humidity and pH. Down here also it's showing the freshwater top off. The last time it ran a top off of the freshwater system, and each of the nutrient cycle down here, like I say, about every 30 minutes it's going to run that. And at the bottom there you can see I've modified the code to make it run more frequently just for this video, but that's how the system operates. It's designed to operate on its own with no need for anyone to have to do really anything. Just plug it in and let it do its thing, and over time you can see the plant start to grow, and then once it's ready to be picked out and used for food, and then you just pick it out and use it and start over again. Or you can trim it and just let it keep growing and provide you a food source for an indefinite period of time. The only thing that would eventually have to get done would be for fresh water to be added to the freshwater reservoir, and at some point you'll run out of nutrient solution. You'll have to replenish your nutrient solution, but that's all. From here you'll be able to grow plants. The thing should scale to any size. This is just a small example of a one plant setup. Very simple, components. There's nothing here that isn't easily available. I got all this stuff really easily online. Very inexpensive parts. And that's it. Thank you very much.